and converting that voltage to a reading of some kind on the meter, and instead of voltage, then they will convert that into ohms. That's all it's doing. It's actually measuring the voltage drop across the resistor that you're connected to. You do the same thing with an ammeter and a voltmeter from your test box. Now the reason that's important to know is because an ohm meter should never be connected in series with a circuit that has power in it. It should be connected in any circuit that has power in it, series or parallel. However, I'll come to that in just a minute. If we have a circuit and we open it and connect the ohm meter in that circuit, and if this is a 30-volt battery, like the one we have here, is a 30-volt battery. Some of you use a 9-volt battery. But if this is a 12-volt battery and this is a 30-volt battery, how many volts are we sending through the circuit? 42. And 42 volts is too much for this unit, and it may be too much for this unit, depending on whether it's an electronic unit or a light. Electronic units will be destroyed a lot more easily. This is an analog type meter which has a dial on it, in other words, a meter on it. Something will be destroyed if you hook those into the power supply. Now, it is not a good idea to hook ohm meters of digital in a power supply. However, there are some ohm meters that can take it. They hook into it, it won't hurt it, and it will still measure resistance, but you won't get the right resistance reading. One of the big mistakes that some of the guys make when they're doing their troubleshooting is testing circuits with the doors open and the dome lights on, measuring the resistance in the circuit, and the electricity is still going through part of that circuit. The ohm meter will give you a reading, but it will not be a true reading. So you can cover your mistakes a little bit with a digital type ohm meter. Keep that in mind. It will not be the true reading. Okay, on certain components then, we want to trace a circuit and find out where the trouble is in that circuit. Let's see if we can make some type of example. Here's a key, a resistor, which we call a ballast resistor on a car. And it may go through a coil, and from that coil to a set of points, and from that points to ground, and back then to the negative side of the battery. If we ask how many volts go to a certain component, then we connect the voltmeter, one leg negative to ground, and the positive leg to the circuit. When I say positive leg, I'm assuming that we have a negative ground system. If it was a positive ground system, then we would reverse both of the voltmeter leads. In other words, if this is a positive ground, then this ground would have to be positive and this one would be negative. Clear? We'll stay with the system right now.
So what you're saying, whatever grounding wire you are, you have to put that, make sure you're grounding up there with the same one.
Or the same polarity. regardless of whether it's a positive or negative ground, just watch polarity. The red or the positive always goes to the positive, regardless of the ground system. Okay, there are maybe specifications that will say that there should be a certain amount of voltage right here to this coil. Let's say it should be 7 volts. The system isn't working the way it should, and so you want to check to find out why. We would connect the voltmeter then to this point and see what the voltage is. What would the voltage reading be right now?
0.
Why is it 0?
Stay connected. Your keys open.
Okay, it's connected
Yeah, but
to the
switch-
circuit, but the circuit is not complete because the switch is open. So electricity cannot flow to the battery on through the circuit. So right now the voltage would read 0. If we connect the voltmeter to the live circuit, which we made by closing the key, looking at the circuit right now, what would the voltmeter read? How much you said? No?
12.
12. 12. Why would it read 12? What does the resistor do? What's the purpose of a resistor?
To change the flow.
Okay, resist the flow of current and drops the voltage. Now, if this is going through a resistor, why do you say this would be 12 volts then? Is the resistor not doing its job? We had one that said it was 7 and one said it's 12.
Well, it wouldn't be quite 12, it'd be a little less. You'd have a little voltage drop coming across that resistor.
Why would we have a little rather than 5?
Because you're just like you're putting rods in a string. You're cutting down the flow, narrowing down the.
Okay, if the resistor is doing what it's supposed to, that's true. But one person has said that it would be 12 volts. Why would it be 12 volts? What's your reasoning for that?
Your points are open, so it's got an open.
You know, you got voltage, but you know amperage.
Okay. With the circuit being open right here, there is no current flow. Remember what I told you, if there's no current flow, there is no voltage drop. So at this point, we would still have 12 volts in our system because no current flow. Resistor can't drop anything if nothing's going through it. That's important to remember. Okay, if we move the voltmeter, well, let's go on with this scenario first of all. If we close the circuit, now current can flow through the system, and we will read voltage of whatever we have there. We gave you the specifications that it should read 7 volts. What does it tell you if it reads 7 volts?
Normal.
It's normal. Everything's okay. What if the voltage reading is 5 volts? Okay. Now, there's too much resistance, but here's where you can sometimes have a fly in the ointment. If this resistance is, we'll say 1.5, and this resistance in here is about 1.8, what type of circuit is it? Parallel or series? So how much resistance is RT?
3.3.
Yeah.
Okay, 3.3 volts. Ohms, excuse me, 3.3 ohms resistance. how much current will flow through that circuit? How do we find that? We use Ohm's law. Putting following this formula, we know the resistance, which is 3.3. We know the voltage because this is a 12-volt battery. So if we divide 3.3 into 12, will give us the amount of current that flows through the circuit. That's going to be 3, 9, 9, 21, which is, what, 7? Almost, not quite. It's actually 6. 3.6 amps will flow through that circuit, right? Now, what happens to current flow if this resistor has less resistance than it's supposed to? It has 1 ohm resistance. What's the total resistance now?
2.5.
2.5. What is the current flow then? .5 into 12 give us 5. Not quite 5, right? Very close to 5. What happened to current flow? Did it go up or did it go down? From our last example. Current flow went up. So as resistance, if we have voltage is equal to I times R. If voltage stays the same, which it did, we did not change the voltage in our battery. And from our last example, let's put our first example up here. RC was 3.3 and the current was about 3.6. In our next example, resistance went what, up or down? Went down?
The resistance went down,
Okay, resistance went down
current flow went up.
and current flow went up. And it'll always do this. That's a fact. We can spend a lot of time on this. Sometimes we'll come back to this again because this is important to realize what happens to the circuit when one of the components changes. Okay, if the current flow went up from 3.6 to 5, what effect will that have on the voltage at this point? If more electricity flows through this resistor, which it will, we just proved that now it's going to have 5 amps flowing through it. Because in the series circuit, whatever goes out this battery goes through all the circuit and back again. The current flow in a series circuit is the same any place you measure it in that circuit. If the current flow went greater through this resistor, what happened to the voltage drop across that resistor? Did it become more or less?
Becomes more.
Less.
Okay, we have 50 becomes more. As the current flow becomes greater through a circuit, the voltage drop will become more. Okay. In other words, if we read 5 volts at this point, it may be because of the wrong resistor here, or it may be because of the wrong resistor here. Either one will cause a change in the voltage drop. To measure the voltage drop across the resistor, case now, we actually measure the applied voltage to the coil. If you want to measure the voltage drop across the resistor, then you connect it across that resistor. In other words, our voltmeter would be connected here and here, and we'll measure the voltage drop across the resistor.
If it's 7 volts, then you know your resistor is the right one. Correct.
Now, okay, if we measure 7 volts here, found it was right, is that the same 7 volts voltage drop that we have here?
It should be the same.
Okay. If we take, technically, what we're doing, if we connect, this is sometimes confusing, and this is where one of the things I wanted to cover, because the applied voltage and the voltage drop is not the same in most cases. It depends on where you're hooked up. So let's see how that works. Let's go back to this a minute. If we say this is 7 volts, let's go back to our original and say that it is meeting the specifications of 7 volts. At that point, what we're really doing, this is the applied voltage to that resistor at that point. But it's also the voltage drop across this coil and these points. In other words, look where the voltmeter is connected. It's the same as if I did this. So the voltage that we're reading here is the applied voltage at this point, or the voltage drop across this portion of the circuit, not the voltage drop across this portion of the circuit.
So the voltage drop right there, the resistor should be 5 volts, correct?
Right here,
Back on that resistor, right there, that should be 5 volts.
that would be 5 volts, because then the 5 and the 7
That is 12.
equals 12. We'll erase it as wet. Okay, so you have to watch where you're connecting the voltmeter to make sure that you're obtaining what you want to obtain. This 5 volts across that resistor, if that does read 5 volts as we put in our example, would mean then there is 0 voltage drop here. Because we have not measured, putting the voltmeter right here, we have not measured the voltage drop in this wire. If you want the voltage drop in that wire, then you connect the voltmeter here. You can connect the voltmeter any place in a circuit that you want to measure the voltage drop across the wire, across a connection, or any resistor. Okay, let's do a little troubleshooting with that in mind. Let's take some examples of some troubleshooting and see if we can find the problem. Take a simple circuit again, or a simple one resistor. This resistor is not working. There's no light. Battery, everything looks like it's connected up all right. So let's go through a series of troubleshooting examples. Where is the first thing, what is the first thing that you would check?
Battery voltage.
Battery, to see if we have any power supply, right? We're going to change these connections. If we check the battery, let's put the voltmeter on the battery posts, and we'll read, we'll say 12 volts. This light still isn't working, so if we move the voltmeter lead, this one lead, from here to the wire, and our voltage is 0, under 12 to 0, what does that tell us?
Got a bad connection in that post.
Okay, let's label it so we can talk what we are. You have an open circuit on the negative post. Questions? I see some question marks out there. Parker?
I'm working on it.
Okay. Let me do the same thing again and put the voltmeter in a little different place.